set to go. So you've had lots of time to read the title, and so it's Oumuamua and the implications for the origin of life on Earth. So it's just a little project that I thought was pretty interesting, and I thought of sharing it with you. And I'll just set up a few slides here to briefly introduce Oumuamua, which you may have heard of, and should just generally ask, everybody here heard of that or familiar with it? A lot of hands go up. So okay, so maybe some hands didn't go up. So I'll just do a quick intro to this little object, and then some more about the implications for life on Earth. And so what is it? It's a really nice picture here, but it's just an artist's impression. And so this is actually a very interesting object. Let's have a look at some details here. It was discovered last October, so it made news around December onward. And so it became pretty interesting when it was discovered that it was a very fast-moving object, but it was discovered by Pan-STARRS 1. Everybody familiar with that? Anybody know what Pan-STARRS 1 stands for? No? Panoramic telescope? Nobody wants to guess? Okay. Anyway, it's this big gadget you see in the lower left here, and so notice Andy didn't mention it in his presentation. Don't bother looking for it. And so when it's discovered, it was around magnitude 23 or so. So it's not really as an observing object. It's just really an interesting object I thought would be worthwhile to point out here. It was discovered about 40 days after its perihelion. That means it had gone by the sun, and then it was discovered after that. And the designation of 1I 2017 is a pretty unusual designation. It's really the first ever designation with the letter I. So you saw Andy demonstrate some designations of comets, 2C and so on. So the I is the first object designated to be an interstellar object. So that's why it's pretty exciting, in my opinion. It's pretty interesting. So it's the first interstellar object confirmed to be interstellar. So some details to just point out a few details that illustrate why it's interstellar. Its orbital details were found to have an eccentricity of 1.2. So normally asteroids, solar system objects have an eccentricity of 1 or less. So a perfect circle has an eccentricity of 1. And generally, orbits are generally elliptical. They have a little bit less than 1 eccentricity. There are some cases where they can be slightly over, maybe 1.02 or something like that. It's also possible for some asteroids to get captured and modified, their orbits modified by big planets. But 1.2 is highest eccentricity ever measured for any object, and it's definitely a hyperbolic trajectory. It's not just hyperbolic, it's strongly hyperbolic. So I put in a picture illustration in the bottom here to illustrate that. Normally asteroids and even most comets orbit generally around the plane of the ecliptic. And so the ecliptic being the plane of a solar system where most of the planets orbit generally in a plane. And so this object came from well outside of a plane, zipped past the sun and Earth, and zips off at another high angle. So I have a better illustration of it. But the other interesting detail is it's a very high velocity object. And so here's possibly a better picture. So it gives you a better perspective. You see the outer solar system, and you see the inner solar system where it's zipped by the sun in October. But you get some impression by the upper diagram here that it's strongly hyperbolic and not part of the solar system. But the speed and the orbital eccentricity make no question about it. This is an interstellar object. So that's why it's special. That's why it was discovered, generated some excitement. There's a few other details about it that are not so relevant, or they're interesting by themselves. And this bottom diagram plots some brightnesses. And so the squares are intended to represent, in this diagram that I used, the brightness. So you see maximum brightness when it's fully illuminated, and it's found to be rotating, but actually rotating in complex axes. So it's actually tumbling, not rotating around one particular axis. So it's not even a variable star. It's a tumbling object. And so you can also get some spectra or measurements of the surface that give some indication of what the composition of the surface is. This is pretty darn tough. And so I read some papers that had some spectral results, and it shows it's generally a red color, and it's approximately similar to some asteroids, but it's not really conclusive. And it's because the object is moving very fast, and very fast moving. It moves out of the field of view, or I should say out of visibility, beyond 23rd magnitude pretty quickly. And so it's very hard for observatories around the world to get some usable spectra. So there are a few measurements in some papers, but they're not really highly conclusive, so I didn't want to dwell on them. So those are just a few details that don't matter an awful lot, but they cause it to be classified because it's mostly metal rich, classified as an asteroid, although at first it was thought to be a comet. And then some spectra came in and people didn't see any comet-like activity, that is to say a tail or a comet around the head, so it got quickly classified as an asteroid. So that's fine, that's the way it was during the winter, first few months of the year. I told Paul, I suggested this idea to Paul. He occasionally sends an email asking if anybody has suggestions for a presentation here. So this was last winter, and I said this would be a very interesting object to present, and so he said, fine, put it together and we'll present it when we get a chance. So I thought I will simply update it whenever news comes in, because there were a few papers appearing from month to month earlier this year. So some news came in March, pointing out that it probably came from a binary star system, and not just any old binary star, but a circumbinary system is one that has two stars orbiting fairly closely together and within each other's gravity. So there are some double stars that are binary stars and pretty far apart from each other and have long orbital periods and don't really have a huge gravitational impact on planets in their vicinity, but close circumbinary systems do have a big impact. And so it was considered by some modeling and other observations that this object very likely came from the planetary formation stage of a circumbinary system. So that may narrow it down to some stars in the stellar neighborhood of our part of the galaxy, or it may not. Just another point of interest, in my opinion. But that was one bit of news that came along in March. Some more news appeared in June. And that was, I thought this was really exciting, at least for the implications for life. And that was, it was decided that it was a comet, not an asteroid. And that's because it was, as it was tracked on its way out of the solar system at very high speed, and I think I mentioned it was dropping below 23rd magnitude pretty quickly, it was found to be accelerating. So even after considering all the gravitational influence of Jupiter, all the planets around, all the minor planets, whatever impact they had on the orbit, and the velocity of this object, it was found to be accelerating slightly. So it was decided it was due to volatility, outgassing of some volatiles from the surface, very similar to what a comet does. And so comets outgas some volatile compounds, so it was reclassified as a comet. And so nice illustration here, but you may get the impression a rock heated by the sun and maybe some jets of gas or volatiles popping off the surface and causing some acceleration in some complex form, considering that it's tumbling irregularly. So that was very interesting news, I thought. So those are the two main news points that came along, and that's basically I've told you all of what's relevant about this object. And so there's some other details, but the main point being it's interstellar, definitely from outside the solar system, and it has some volatile material on it. That's what I thought was very interesting. So that's what I'm going to tell you about Oumuamua. So I also wanted to tell you about some aspects of life forming on Earth, because it's closely related to this object, or it could be, or you may decide for yourself. And so I should stop playing with this, and I should press the correct button and advance to the next slide. And so I don't know, I wasn't sure how much stuff to mention about this. Anybody familiar with abiogenesis? Not too many hands. Andy is. Anybody familiar with the idea of panspermia? A few more hands. Okay, good. So in that case, I'll spend a few minutes talking about some ideas about abiogenesis. And so this is the idea that life could have developed from non-living matter on the Earth. And it requires some stuff to be in place. Specific chemicals need to be in place, need a good source of energy, and we have to have the formation of self-replicating molecules, which is basically a definition of life in the simplest definition. So those are some requirements. We need to have some chemistry present, and on Earth we have carbon and water, and so all Earth-based life is carbon-based. So there is lots of carbon, fortunately, and there is water, and there was lots of water present in Earth's early atmosphere and in oceans. So besides that, we specifically need certain chemicals, amino acids, which are proteins, carbohydrates, some sort of fuel source that a cell can use. Need to have lipids, which are fairly complex forms of organic chemicals that form a fatty tissue membrane to surround the cell and encapsulate a cell and allow it to survive by itself. And there's also something called RNA, or nucleic acid. So you may or may not be familiar with all of this. I didn't want to get in too deeply into chemistry or biochemistry or geochemistry, but it is quite relevant. So I'll mention a few more details. I think besides chemistry, I need to have an energy source to start all this. And so nice illustration here, a nice colorful illustration illustrates a lot of these features. There are some sources of energy that could do the job. Ultraviolet radiation from sunlight, ionizing radiation, geothermal radiation. You may get the impression it may be representing a volcano here, but and there may be some, you could imagine some lightning coming from cumulonimbus sort of clouds that could build up. Volcanoes, lightning, impact events. So you could sort of get the impression in the early Earth, a lot of objects slamming into the atmosphere or even the surface, causing impact events and possibly transporting some of those important chemicals that I mentioned. So those are energy sources that we need and have, and were present. Some other conditions that were present on the early Earth, we did have water oceans, did have the correct sort of atmosphere in place, and some chemicals were known to exist pretty early. Methane and ammonia are just fairly simple compounds of carbon with hydrogen and nitrogen with hydrogen, and some other things, hydrogen and sulfur compounds. Metals and minerals may be pretty helpful for being catalysts that will help the process get started. Hydrogen and cyanide came from comets. We know that's on comets, so it's a good source of the chemistry and the energy available on the early Earth that could have helped life start by itself, the abiogenesis process. I don't know if anybody's heard of the Urey-Miller experiment. I'm not sure how famous it is, but maybe not. So maybe a few people may have heard of it, may not have. This is an interesting experiment for the to help out with the idea of life forming by itself on Earth. And this was simply a case where Mr. Miller put some fairly simple chemical compounds together and mixed them together into a flask and put in an electrical discharge to represent lightning, defective lightning. I left it for a week in the lab to see what would happen. And after a week or so, it was found that it had formed amino acids, sugars, and lipids, just the conditions needed to form life. So that was a very interesting experiment half a century ago. There are some other places on Earth where life could have begun. I don't know if anybody's familiar with hydrothermal vents. Maybe, okay, good, some people are. So in case you're not, these are very interesting places in the bottom of the oceans where extremely hot water is percolating out through the crust, pulling some minerals from the crust with it and percolating into the ocean. And with these vents, it's a little ecosystem all by itself. So sulfur, hydrogen, all sorts of chemicals are in place with a lot of heat and a lot of interesting chemistry going on at the base of the ocean where these hydrothermal vents are blasting out of the crust. And also, near these vents, there are some interesting life forms. So there are some weird, strange, unique life forms that exist around these hydrothermal vents. So it's just one illustration of one possible location on Earth where life could have begun, at the base of the oceans. There are others as well, but I'm just going to summarize it here just by saying there's a lot of evidence to support the idea that life could have begun by itself in the abiogenesis process on Earth. So the other idea of panspermia involves the seeds of life being everywhere in the universe, or at least scattered anywhere, if not necessarily everywhere. So the point here is that building blocks of life, those chemicals I pointed out, amino acids, lipids, and so on, could have been brought to Earth from space. So I showed you illustrations showing meteors or some sort of objects blasting into Earth, and you could just sort of picture some potential chemicals blasting into the Earth, a local source of energy wherever it blasts into the ocean or the surface, and some spots here or there where life could have begun. Is there any evidence? Sure there is. There's lots of evidence. Some meteorites have been found to contain these amino acids. There's a lot of water and volatile organic compounds found on comets. And a lot of other bodies in the solar system are known by now to have water and organic compounds. And so I think this is a big, exciting development in the past decade or so, where previously it was speculated that water might exist on Mars or other locations, and now it's known to have be in oceans under the crust of Europa and Enceladus and other spots. And I put in a picture. You notice Andy mentioned Cirrus, so here's a picture of Cirrus, and what was interesting a few years ago, speculated to possibly be ice or water. It's now known that it is water. It's from the Dawn spacecraft that noticed this white spot that was a mystery a few years ago. Anybody remember that? Anybody remember what a mystery it was a few years ago? So it's very interesting development in the past few years that now it's widely known that water is all over the place, including other stars. So there's lots of evidence for the building blocks of life being in space and could have been transported to the Earth. And that's basically the basis of the Panspermia process. There's another process that was fairly relevant, and you may have heard of late heavy bombardment, which is generally considered to be the period in geological history when the moon got most of its craters. A lot of objects impacted the Earth as well, but because of plate tectonics, there are a lot of meteor impact craters are covered up and smoothed over, whereas on the moon, the evidence is right there. So the point of it being about 4 billion years ago when this period ended is that life could have begun, and if I didn't mention, life began on Earth. It's known to have begun approximately in the range of 3.5 to 3.8 billion years ago. So the oldest fossils are known to be about that age. So coincides very approximately with the end of a late heavy bombardment. So this is when a large number of asteroids collided with the planets. I mentioned the moon. Other planets, including Mars and Mercury, have craters. So the main point here is it's the possible source of Earth's water that have a similar deuterium to hydrogen ratios. So comets don't have water that has the appropriate ratio of deuterium to hydrogen that Earth has, whereas a lot of asteroids do. So it's one possible source of Earth's water. So we have a lot of aspects in place to support the panspermia process. We know space is a pretty hostile environment. Things travel through space. There's irradiation. There's pretty darn cold temperatures. There's pretty hot temperatures facing the sun. So pretty hostile environment. However, we do know that the comets can have a crust over them and have water beneath them and volatile compounds that survive this hostile environment. So there's lots of evidence for panspermia. So back to Oumuamua. These any asteroids or comets are a potential source of the organic compounds that could have been the building blocks for life on Earth. Now we have interstellar objects as well. So to me, it's exciting because it vastly improves and increases the range of potential possibilities for source regions for life. So whether you see life as beginning as the building blocks of life, these compounds I pointed out that had to come together on Earth, or if you say that life began somewhere as cells and got transported to Earth that way, now that we have interstellar objects known to be whizzing by the Earth and the solar system, to me it just means that the range of possibilities is vastly increased. It's already known or well considered that thousands of interstellar objects may already exist in our solar system that originated elsewhere and are captured by the gravity of the solar system. And that's fine. That's been speculated for years. Until now, there were no facts to support it. Now we do have one observation. So that's basically all I set out to tell you about. So before I get to my final slide, I did want to mention one other aspect of these very high-speed interstellar rocks, their impact on Earth. Anybody want to guess what that is? If you don't, I'll just go on to the next slide. So it's not a positive effect, I'll have to admit, but if anybody remembers this object in Russia about 5 years ago, this was a lot of energy that came in, and fortunately it disintegrated in the atmosphere, and fortunately only shock waves came down and broke windows and caused some damage, quite a lot of damage actually, and injuries. And so the point about space rocks coming into the Earth is that now that we know that there are potentially big rocks, potentially very high speed, it's not a good idea for continuing life on Earth. So it's a potential negative impact for life on Earth. However, that's one thing I thought I ought to mention with the possibility of high speed interstellar rocks coming in. So final slide is just looking at the future. And so we saw with this telescope called Pan-STARRS 1, it's actually one of a pair that's being developed. It's discovering quite a lot of objects, and as I mentioned, it was around 23rd magnitude or so, and it means the potential for discovery of many more objects, whether they be comets, asteroids, combination of the two, or possibly objects we haven't heard of yet. Smaller and smaller objects may be discovered. That's the idea with the idea of the near-Earth object observing campaigns that are underway to try to catalog and classify these objects. There are some big telescopes coming online in the next few years. Giant Magellan Telescope, European Large Telescope, possibly 30-meter telescope. Don't want to talk too much about the politics of that one, but the main point is new objects will be discovered. And as I mentioned, the excitement, it seems to me, is the potential increasing range of source objects for potential life and the building blocks that could have started life on Earth. So that's all I set out to tell you, and so I'll stop here, and any questions, I'll try to deflect them as well as I can. And any questions?
Have they traced back the source of our interstellar visitor as to where it came from?
So the source of the interstellar visitor, short answer is no. The longer answer is some modeling has been done and presented in some papers saying that it probably came from one of the stars in the vicinity of the solar system. However, other papers are saying it could have been flying through interstellar space for millions of years and could have come from anywhere. So first speculation was that it came from the direction of Vega, which is the direction that the solar system is moving in the sky. However, I favor the speculation more that it could have been in space for millions of years and not necessarily came from our stellar neighborhood. So that's the best answer there is for that. Anything else? I would say we're finished, Paul.
No more questions? Okay, well.
That interstellar object, fine. What was the source of the origin of that, material?
So the source of the origin, so it's interesting because the question of whether it's a rock or a comet is interesting because the speculation is that it came from, most likely got ejected from a circumbinary pair of stars. And so the point about star formation is that the planetary formation stage of a star and a solar system, rocks and debris left over from the accretion process where the star form a disk around the star, accretion disk that gradually separates from the planets. There are some planets and there are a lot of gravitational interactions where smaller objects get flung out, gravitationally flung out of the system far away. And so it's considered that rocks that are closer in than the so-called melting line, or what's sometimes called a snow line or an ice line, a certain distance from the star, where things are separated into either rock or water ice objects. Things closer in are rock, and they can get flung out and they become asteroids, or what we see as generally rocky or stony asteroids. The farther out objects are mostly water and dust, and they get flung out as comets. So it's generally considered by some people who have studied it, done some modeling, that the objects that we will find as interstellar objects will be mostly comets rather than asteroids. That's because they're farther away from their parent star, they're easier to get flung out by gravity. But in this case, it was considered to be most likely flung out by a circumbinary pair of stars that had more gravitational influence, that had made it easier for the object to get flung out. So that's the best speculation of where it came from. Hyperbolic orbit, yep. Okay, so the question is about the hyperbolic orbit. So will it come back, and if so, what is its period? So it's hyperbolic orbit means it's not coming back. It's a one-way path through the solar system. So the eccentricity of greater than 1 means that it's an open orbit, or it's not bound gravitationally. It just got came in the direction of the sun, got it gravitationally attracted by the sun to have its orbit bent, but it's not a closed orbit. So it's not coming back, and so there's no answer to the period. There is no period. Okay?
Go ahead.
How fast it's traveling, and how does that relate to other objects that similar comets or asteroids that may be in motion?
So it's a good question about the speed. So I didn't, I wanted to keep numbers out of this as much as possible. So I don't remember, there is some number for the speed. It was found to be some number of kilometers per second, it's some high number, but I didn't put it in here, and it's not too relevant because the main point is how it compares to other objects. It's much faster than any other object ever seen. Much faster than any asteroid bound in an orbit around the sun. So that's one reason why it's considered to be really special, really interstellar, and one reason why it occurred to me to be potentially very destructive to the Earth if a very high-speed rock hits the Earth and we can't see it coming. So I don't have the answer in kilometers per second. There is a number published for it. I just didn't bother to put it down here or memorize it. So that's the answer to that one.
So
Go on.
it's my first time here. I'm just a neophyte with all this, so I apologize if this is too simplistic a question. But did I understand right that 4 billion years ago the planet Earth existed, but there was some huge influx of flying debris that hit it? Is that what you were saying? And may have hit Mars and.
Exactly that. So the question always is, I'm not sure, of course we welcome new members here all the time, or anybody that wants to walk in, so I'm never sure how much detail to put in, but the quick rundown of the formation of a solar system is that it's considered to be approximately 5 billion years old, or 4.5, and this is a non-religious response, but approximately 4.5 to 5 billion years old is when the solar system formed out of the accretion disk or disk of material from which the sun coalesced and condensed into the sun. There's a big disk of debris remaining around it, formed planets, or the thicker, the heavier, more dense objects attracted more debris and formed planets, the planets that we have now. There's a lot of smaller junk left flying around, asteroids, comets, wherever they were. So it's considered, because of gravitational influences from the other planets, it's considered that about 4 billion years ago, after the solar system had formed, but 4 billion years ago from now is the general time range it's considered to be. Yes, there's a huge period of more asteroids than before or after, bombarding the Earth and all of the inner solar system. So that's been found by lunar crater ages, craters found on Mars and on Mercury, where there's no plate tectonics to erase the craters that are evidence of that. So if you're asking about, did I understand it correctly? Yes, it was called heavy bombardment because it was a relatively bombarding period in the formation of the Earth. My point was that when that finished, coincides approximately with the time when life began, according to our oldest fossils. So does that sort of answer your question? Okay. Guess you ran out of questions, Paul.
There was one question from the web. Just about the shape of our visitor. Is any thoughts or ideas on why it would end up being in quite that shape?
So the shape of it, you see it had an aspect ratio of approximately 10 to 1, or approximately 10 times longer than it is wide. So it's considered to be a rock that formed in collision in its solar system, wherever that was, formed by collisions. That's how it formed chunks. So that's the formation of asteroids in general. Just a bunch of rocks colliding, and it was considered to be just simply a collision. So I don't think there's any more information about it than that. Been a few papers about that implies that its origin was from a collision, but it just confirms that it was an early solar system somewhere where there were a lot of collisions in the process of accretion and collision in its formation.
Great.
So, okay.
Thank you.
Okay, Paul, I think we're done.
Thank you very much, Frank.